Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and or typing systems and whether or not, new programming languages can be hated or loved and libraries for same and all those kinds of things. Um, we're all recorded. We're up on YouTube in a couple hours. I normally have no set agenda. I was going to share experience coding in simple. I know there's a bunch of people here who were looking to talk at one point or another. Like, Alan, do you have slides that you want to do again or not?
No, no, I don't have anything. Sorry.
You're actually good. Okay, well, I'm going to roll, and then I'll come back around to, whoever else wants to go next or open conversations afterwards. Let me go see if I can do something here. Um, is that now readable?
Yeah.
Yeah, so I'm attempting to read. Let's start here. I'm attempting to do one of these programs, which is go read a bunch of characters and bubble sort them. So the generic message here is read a line, something that looks like that, and bubble sort it. Now this is simple code. It's in the middle of everything. I have no debugger for simple, no language library support, nothing. So it's all first principle shit. So it's been a wild ride. Things work, things don't. And of course, I get bugs in code gen and bugs in encodings and bugs here and there come around. And then sometimes it works and it works instantly and it's great. And then other times it's just like, what the hell's going on? So here is like starting from the top for no good reason. There's just a short exit, print a message. So sys.io.p is print to standard error an array of bytes. And sys.libc.exit is call exit, which obviously ends the process. And the uses message, like if you're giving any bad input for this particular case, you should print something that's a usage error and get out. And then I made a scanner struct. It's just got two fields. It's got a mutable X. It's got an immutable array of U8s, so a byte array. And then I don't have any instance methods. I have no methods. That's like next chapter. That'll be go with strings. So this is all byte arrays. There's no real strings here. So here's skip whitespace, which is just walk the buffer advancing X until you're greater than 32. I could make a space here if you want. And then here is skip whitespace and require a particular syntax token, which if you don't find it, you hit usage, which calls exit and you're out. Otherwise, you're good. Peek is query. And if you don't find it, it's false. If you do find it, you consume the character you're peeking at, and then you say yes. Here's parse a number, skip some white space, the classic. Grab a character. If it's between 0 and 9, multiply the base and add. It doesn't even handle negative numbers, certainly nothing with floats or anything. And then I got a scanner. So let me not just rattle off what you're looking at, but this is like I'm writing simple code. It's actually pretty reasonable to write. Um, Cameron, you pointed out last week that no one needs immutable by default locals. I agree. That would be no bang there. So that's a thing that as usability, I think I'm going to change. That would also get rid of the bang here. I don't have any vectors or resizable arrays, no array lists. So I just pick 16 and there have to be a resizing when I'm parsing my numbers. But peek for the empty list. No. Okay. While I'm not at end of buffer, get a number. Go to my list of numbers. Oh, this is like leftover shit for debugging. Peek for a comma, and if I don't, I better have it close the list. And if I do have a comma, I'm going to go back around and go and get another number. And then I have a print, and I choked on the print because I hit an internal compiler bug, and that was where I was when I left it. So I commented some stuff out. And if I just hit this, this is me just calling simple as a command line driver. So I'm echoing standard in to the output. So this is launched simple process, -s, print the disassembly. Here's your simple program. He compiles, links it, and runs it. Reads from standard in and carries on. So this is the generated code. Here's code for peek. All right, here's the code for whatever. Oh, I skipped ahead here, wherever it went. Print, yeah, print, which just shuffles the args and then calls the libc write call. And here's require and skip, and here's main goes on ways. And then at the bottom, he exits with a 3, which is the number of numbers parsed, and he fails to print because that's my current state of the program. So it's like it like works. It's like quick. The error, like I said, the error messages are terrible. The generated code is reasonable. It's not great. Encoding bugs show up left and right. Uh, that's probably what this next bug is. I had a recent multiply. Here it is. The multiply encoding was wrong. Multiply by an immediate constant 10 was wrong. And there was another one of the set. I don't have and or working, so I used a binary operation. I'll show you the code, which means that I need to generate a 0, 1, which means I need a set, which means you need a set with a higher order bit set in the Rex flag because blah, 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 this and that, God knows what. Like this guy here is using a binary and because I don't have an and in the parser here. So he generates a 0 and a 1, 0 or 1 for the less than comparisons, less than equal comparisons, and then ands them together. Anyhow, that was the excuse me. That was the I'm so excited because I can write code in it and it runs. And at various points, I've had it more or less running, obviously, things like if I stop here, I have to get a number and I exit. Let's see here. I have to make I have to chop my in to an I32. That's a cast. So I can call sys dot libc dot exit on cue. See what happens here. And he says exit code 12 because I parsed the first number up here, which is number 12. So he's parsing a 12, doing all the right things. So that was my excitement. Yes, Zoom is hiding the share controls, so I can't stop sharing. It's wild. He hides his own controls from himself. So it's writable. It looks readable to me. It was able to do shit. So that sys thing, that's a standard import written in simple. So I can add more bindings and standard libraries by simply editing the simple code. And you just rolls it.
Ship
All
the
right.
book.
Sorry?
I said ship the book.
Exactly. Yeah, well, the README needs some more love too, but yeah, it's getting there. And Tommy never makes these meetings, but he's been piling in pretty steady here. A lot of this stuff works on RISC and ARM as well under simulation. And somebody was messing around with an ARM. Oh, Derek's not here. He has an actual ARM Mac. And we didn't quite get to where the Mac was running, but I suspect it's pretty close. I think we need a little bit of libc variation love, and then we'll be running on an actual ARM chip. And then running on Mac as well. That'd be nice. So there you go.
Very cool.
All right. It has to be somebody else's turn here.
I have a potentially short or long topic, which is I've I output for my stuff. I do RiscV machine code, and I stumbled upon this thing which I want to know people's opinions of, which is on RiscV, and this might exist on multiple architectures as well. For say call instructions, they have the jump and link register, and that has a slot for the destination register, for example, for the return address and the source address of, where are we jumping to, etc. And I find that I basically only use register 1, the return address, because when I'm doing a call, I want to build the destination in the return address, and then because it's going to get clobbered anyway, and then I do the call, and then when I return. So what do people here think that that was a good idea, how they designed it? Because it seems a little bit encoding wise, it seems simple but wasteful to have, supporting all the 32 registers.
It's just a matter of you let the allocator pick, and then you can choose to not spill any memory for leaf calls. So standard old school, really old school calling technology pre-stack. So no stacks. Everyone gets one word for their return because since they're not recursion, they need one word for the return, not an infinite number. So that one word would be in memory normally, but it could be just in a register. So A can call B, can call C, can call D, can unwind all the way back to A, and there's no memory references at all.
Okay, and do you code gen for that? Like, do you find that useful? And I presume then you'd have to um, adjust the sea of nodes, or you'd have to have a node that's at the granularity of this jump and link register instructions so they can freely
Yep,
allocate.
that they are. And I don't tell the allocator anything particular. And he will, other than he expects the calling convention expects R1, the standard RPC. But that's just because I've picked the calling convention. There's nothing about the encoding or the RA, the register allocator, that cares. So it is a plan or a futureness here to go and change the calling convention. So, when calling normal libc things, I'll use the standard convention. But when simple calls simple, all these restrictions on what registers land and what places go out the window, and the allocator does what he does. And it might mean
Mhm.
a different set of registers for every individual call, and that's fine. Including R1 could be all over the map. And the goal there is to simply say I have fewer spills because I'm not required to save and restore whatever things across the call, because this call uses this set of registers and that call uses that set of registers, and there the twain shall meet, and so I don't have any allocation issues and so on. So there's definitely a thing there that in theory will cut out an interesting amount of spills. And all I have to do is turn off named registers. Like you're using the R1 mask. Instead, I'll change it to you're using the full, writable mask. And
How do you think that interacts with caller saved versus callee saved
yeah,
registers?
same. That was a part and parcel of the same deal.
Or
As soon
but
as,
do you also live pick that when
yeah,
you
yeah,
so
there's
you,
no
you could
reason
have
not to.
yeah.
Like, from the allocator's point of view, he doesn't care. So if he allocates this function and he has some set of caller saves and everything else does whatever he does, if he's blending, if I'm doing independent allocation per a function, then I'll just tell you when I'm done with that function what the caller or callee save combos are. But it depends on that allocation depends on some other function. So if I were to allocate bottom up, then the leaf functions would have all the freedom in the world to burn registers any which way they like, and the next layer up would take advantage of that to burn registers according to whatever, use them however it goes. My current actual theory is that, and in fact, what I'm doing exactly right now is I'm just running the whole compilation unit and the allocator all at once. And he is simultaneously allocating all functions all at once, which means as
Mm.
soon as I throw out these register constraints at the call sites, he'll he'll just pick things that magically for this entire compilation unit magically don't stomp each other. And in theory, I'll be able to get rid of, I'd like to believe I get rid of, 50% of my caller save overheads.
So you think it was a good design then? It doesn't seem to me like when they made this decision, it seems very speculative, right,
I
design wise.
I think, well, I think yes. I think there's some history there for people who saw the benefits that could have, should have, would have been when they're handwriting assembly to go skip around the registers and not have to clobber memory. And then if you're into like tiny embedded versions of things, like you're using the 16 register version of R5, it's like what Derek's using, and you're expecting to have very few function calls and also very little memory. Having a variant R1 means you can make a function call in and out without using memory.
Hmm.
This is like
Right, and presumably the constraint there is if we had more memory, it wouldn't matter as much because we could just inline more? Or
No, it's because you don't run out of stack. There's a couple constraints here. One of them is how small is small, and one of them is how much juice you burn. So in Derek's case, it's really small. He's got 8 kilobyte.
Mhm.
So he just cannot run a classical stack operation. He'll just run out. So he doesn't expect to have, and most of those that kilobyte, by the way, is going to be filled with constants for doing. It's an AI chip. He's going to have matrix setup constants of various kinds, and they'll vary from the die's big, got bajillion of these R5s all over it, but each R5 has 1K
Mm.
or maybe 8K, something. It's something really small. Um, so there's 100,000 of them on a die, but each one's got its own private memory and it's tiny. Fine. Um, so he doesn't want to burn a lot of stack. He doesn't actually want to manifest the stack. He wants to be stackless. And I can imagine that being true for any tiny embedded chip. You just don't need a stack if you're not going to do recursion. Fine.
But do you need calls if you're not going to do recursion?
Do I need cores?
No, no, calls, as in, do you even need
Oh,
function calls?
yes, because there's still repetition.
Uh-huh.
Like,
So at this point, it becomes like a compression scheme
yeah, it's a
in a
compression
way,
scheme.
right?
Yes,
Okay.
yes. So the other piece of that is burning battery because running the memory burns more juice than not running the memory. So if you have a battery-powered embedded device, tiny thing, so your phone gets tons and tons of batteries, relatively speaking. But if I'm running some, infinitely small thing that's getting its juice from either picking up ambient, radiation from your fluorescent lights, or it's got the world's smallest, LCD for a solar panel or whatever, but it's, an RFID on my fucking chip, your credit card chip. He picks
Mm.
up a little RF radiation and then he does something. Okay, so you got some tiny amount of battery. Every time you run a memory cycle, that's way more juice than running a CPU cycle without memory. So you
Hmm.
want to cut down memory cycles as part of lower battery consumption. And if you're not in that domain, you're not. If I'm plugged into the wall, fuck it. I don't care.
So is the um is there a trade-off here, or is there just
Yeah.
a strict good thing that you should do?
Oh, I
Presumably
see what you're
there's like a
saying.
maxima.
I can't say. There's obviously a trade-off. You're better at some things and worse than others. You burn a lot of, Risk burned a lot of encoding space to get that option in. On the other hand, it's not the end of the world to burn some encoding space here.
Mhm.
Everyone's got more encoding space than they need opcodes for in general, and you lost some here and you gained some there, so you burned an opcode and you had to add an extra instruction over there. Only x86 does the infinite prefixes, so I can have an infinite thing because he burns infinite engineering costs for infinite, transistors. For everyone else, a little encoding here, a little encoding there. You add an instruction here, you lose an instruction there. So I claim we're talking cherry picking. It's not like it's
Oh yeah, yeah.
okay.
Right. But you'd still expect a real like a tangible win from having this sort of
It,
free-for-all
I think
allocation.
it is possible to have a tangible win. You have to act on it or code for it. And if you're doing hand roll assembly on a tiny embedded device, you can, and it probably pays specifically there. If you're trying to do it on a heavyweight register allocator you get out of LLVM or GCC, they're not going to probably make much room out of it, much hay out of it.
Mm.
I think I can make hay out of it because I'm going to run an allocator that's going to try to allocate everybody all at once and take
Mm.
advantage of exactly changing calling convention. And that would work for everybody's calling convention, by the way. That has nothing to do with R5s. It just means the RPC is one more thing I can flex on.
Do you have I hate to use the word pass, but do you have some mechanism for splitting things? So the inverse of an inline. I'm
Yeah,
thinking if
outline.
you
Yeah,
you outline, and
yeah.
what are the conditions uh when you how do you detect want to outline?
So as soon as you go to the embedded compiler guys and ask the embedded compiler flags, and somebody will say, yes, we do outlining. And then you can go look up the academic papers on what outlining is. I have never written an outlining pass per se, but I have
Okay.
certainly read the papers. I understand the theory.
Uh-huh.
Instead, I'm careful on the inlining that I don't blow iCache. And the
Okay. Okay.
reason there, yeah, yeah.
Mhm.
In the non-embedded space, the outline versus inline is iCache. In the embedded space, it's you just ran out. You inline too much and oh, we only got 2K of code space or 1K of code space and you're over the budget. So
Yeah.
didn't work.
Yasa told me the biggest reason to do inlining was for optimization
Yeah.
reasons.
Yeah.
And so does it make sense to be in a universe where you say, I'm going to inline, 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 so I can do lots of optimization, have all the nodes float, and then I'm going to try re-outline
Yeah,
to
it
sort of
totally does.
compress afterwards?
Yeah, yeah, it totally does.
Okay.
A similar effect is you want to inline just the partial pieces. So if I inline everything and I optimize, maybe I have trouble outlining because of stupid minor variations on differences. But the outlining gain could be large and that it cuts my code space down. It effectively means my iCache gets higher hit rates. So I effectively increase my iCache if I can successfully outline. So another version of that is to inline incrementally, I guess is a better way to think about it. Because many methods start with a cutout. If n is null, return false. Else, do something complicated with n.
Hmm.
And if you get the n is null inlined, then you can fold that test with other references
Mm.
to n being null or not. Uh, and then the complicated shit's off to the side in its own function if, in fact, you need to go do the complicated shit. But you didn't inline the giant complicated shit. And maybe on this particular zone or area of space of the code, n is always null. There are plenty of places
Mm.
where,
Yeah.
it's either always or never.
And you can elide the call even,
Yeah,
I guess.
right.
Yeah.
Well, even if you left the call in the code, it's not in your iCache because you're never calling it,
Yeah. Yeah.
right? And it's not taking up iCache space lines. You're not doing if, in, jump around, and then all the code eats the cache line up. No, no, no. You just got the thing right there. So there's a lot of things can happen for the inlining. That's good, but not necessarily everything. Yeah, you can blow yourself out there.
Mm. Okay, great. My questions and questions I didn't know to ask have been answered. Thank
There
you.
you go. All right. Cameron, did
I
you want to
guess.
talk about ecstasy anything? You were poking stuff around on the ecstasy forum.
Yeah, I've been busy working on the runtime project, so it's still, still fairly early stage, but we've been working through some of the things that don't translate directly that you're aware of from your own work. The duck typing one is kind of interesting. Um,
I thought I had that
since
sorted out.
what's that?
I thought that was sorted out as piles of interfaces, not positive now.
Well, the issue with duck typing is you don't know what type something will be until runtime. So
Yeah,
so um so if you're generating the code, you don't know what interfaces to tag it with.
I thought I had that sorted. I'm trying to remember now what I did.
Is it like it has to implement interfaces dynamic?
Yeah, the duck
Or
typing, I was doing that with AA too. The duck typing is simply, you don't have to name the interface, but if you have the fields, you can make the call. So I'm calling a hash table, which in some world it needs to be considered hashable, but all it really needs is a hash code and an equality check. So you don't declare your object as hashable, but you have a hash code and you have it equals, then you're allowed to make the call. And if you don't, then the compiler tells you, you don't have an equals call. I can't hash you.
so you search for the names, not for the what it
Yeah,
or for
right. At the compiler searches for the types before he declares you type safe. Then the next sort of implementation grief that comes out of that is when you have a classical single inheritance hierarchy, you can organize all your function calls in a tree-like structure according to their subclassing in the hierarchy. And the common prefix goes early in this tree. So you get, for any individual class, you get a list of functions it implements. They're in a line order where they all share the prefix and the suffixes differ according to which arm of the tree you're on. In that model, when I declare you hashable as a class, your base class is hashable somewhere, then I know the prefix has hash code and equals and what other things you need in the certain early parts of the hash table, and sorry, in the V table. Then when you generate the code for the hash guy, he says, I can generate table offsets at fixed locations to pick up the hash code or the equals or whatever call that you have to have there. Because your prefixes are all the same for if you're a subclass of a particular guy. So you get this really efficient code gen. And that is in fact part of what comes out of Hotspot's inline caching speed ups. When you go to an interface, and duck typing is just interface without the name interface. When you go to an interface, those calls do not have a common shared prefix. They're not organized in a tree-like fashion. So when it comes to, I'm in some call that is making an interface-based call, I can't do a vtable plus fixed node offset, grab the function code and call it. I have to find the guy in the vtable. And that means I have to search. And that's generally, in Hotspot, that's done as a linear scan, looking for the matching signature. So you said, I need to call EQ for equals, or I needed to call print, or I needed to call size of, or what the fuck, I need to call something. So you have a list of all the functions you implement. I need a size of out of you. It's not at a fixed location relative to every other guy who calls the same code. So the dude who's looking for size of says, I got a list of guys, all the functions you implement. The compiler told me there's a size of in here somewhere. Go find it. So I have to go, na, 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 na. Oh, I found the size of call. Okay. Well, if you're doing Hotspot and you are doing crazy counts of interfaces, like say you're doing JPython or JRuby or whatever, and everything's an interface call, and you don't have one or two interfaces, you have everything's an interface, hundreds of interfaces, then every single function call is an interface call, and they all look like scan 100 things looking for the dude, and it's in the middle somewhere. So I have 50 loops around for every single function call, and you drown the death of interface lookups. And that is your overhead. That is what cost. That is the primary major cost. So
Can we
Ruby,
invert
Python, JRuby.
can we invert the question? So for each method is implemented by this set of classes or
So the runtime, the dynamic system of Java is I load a new class. So I don't know who has what.
Mm-hmm.
And if you invert the question, you still have the problem of how many people implement a hash code.
It doesn't support that natively.
Hundreds. Yeah, it doesn't. Well, it doesn't, right? So this kind of thinking went around the early versions when Java was first coming out of how do you support a dynamically loaded set of classes where you have the incremental cost to update the table. So you make some sort of table, and you can get a fast lookup out of a fixed known set of things, sort of relatively easy. Then when you come and add a new class in, can you incrementally adjust the table? And the answer came back was no one found a really good way to do that. I guess Marcus would talk to you about JRocket has some reasonable versions. There's some badder versions that weren't terrible. The other piece of that is that table that you did the lookup in got you something. The table offsets wanted to be generated directly in the code. So if you adjusted the table, you had to go to all the places where that table lived in the code and fiddle them. And if you did that while the processor was running, he could get any version of the old or the new fiddle. So then you get into stop the world to load a class and adjust the tables, flush everyone's iCache, and go again. So, the way Hotspot's done, the limitations, they don't require that. You can dynamically load classes. You can extend everyone's table. You do not have to flush iCaches everywhere, inline caches everywhere. You don't flush iCaches everywhere either. So it's a much faster way to just dynamically load shit and go. And then Java made a lot of mileage out of that. So it's badly solvable. How about that with a lot of work? I know those papers exist. I don't know what the in state of the art is. I know JRocket did something along those lines.
Wouldn't the JavaScript engine's execution model or inline cache model there be the key or a very simple way to solve this? You have your function that calls by interface, and you simply remember like the last 3, 4 interfaces that you saw.
Yeah, right. It's exactly what Java does. He remembers last one for interface calls. If that works, you're great. You could change that to 2 or 3. The issue with these things is that you don't use 2s or 3s. You use 50s and 100s. And now you can't remember the last 50 or 100. You're just doing the linear scan in the generated code, and your iCache blows out, and you have giant things or whatever. It doesn't right. You're back to
Because
square one.
of that, we got rid of ICCs for Falcon generated code. We found that we either have a profile, like several profiled types, and we just generate the dispatch statically for them. Or if there is too many, it's a truly megamorphic call site, and ICC actually hurts. So it's just better to inline the lookup and then indirect call.
So you have more profile data based on sort of history runs that lets you.
Yeah, I think we generate up to six types. We profile, I think, up to 16, and generate type switches up to 6.
Interesting. So the inline cache that was sort of classic hotspot always had this flavor that it was highly bimodal. You either hit it like 95% it worked, and it had a very cheap test and branch. And then the 5% that didn't work, you generally went megamorphic right away, and it cost you an extra branch, and you ran off to a stub that did the lookup and then ran off and did the
So
thing.
I think this ICC approach works well if you don't aggressively devirtualize or do profile guided devirtualization. Because, yeah, if you just look at all the call sites, most of them are monomorphic. But if you are very aggressive at statically proving this, or like proving this through profile, if you end up with ICC, it's a truly megamorphic call because you handled all the monomorphic ones in different ways.
You're devirtualizing at a higher level. Like when I was at Hotspot, we didn't specifically inline to devirtualize. I want to say aggressively. We did it when it was obviously in our face. But there were plenty of times when you wanted to have the obvious one is any hot loop over the complicated iterator, and the inner loop wanted to change. It was bit slice and or XOR and mask cap with clamp blah blah blah, and the tiny inlines wanted to be inlined, but then they needed to be the whole giant outer loop needed to be inlined once for each of the variant inlines. But that required like heavy profiling, that was worthwhile, or you'd get iCache blowout because you were blowing up giant pieces of code to inline some tiny function, which you're saying that you could do because you've done all more aggressive profiling.
Yeah, I think we are probably somewhere on the verge of doing this inlining and code cloning too much. But overall, I think, yeah.
But you hit some threshold where you no longer see inline caches that are, well, you either have it statically, and if you don't have it statically, it's almost always megamorphic.
Yeah.
Interesting. Well, okay, cool.
And with ICC, you do the code patching, which in multi-threaded environment is not nice.
I sorted that out a long time ago. It doesn't actually cost anything at runtime. It's a bunch of engineering, but the generated code is fine. The actual patching is fast. No one's blocked. No one's stopped. That one got sorted out.
If you are just executing the same code from multiple threads, you're hitting different types. They're all writing different types into the cache. Isn't it the problem?
No. The rule there is if I'm going to update the cache, I'm going to have a. I did this at Azul, not at Sun, at Azul, which I don't know if that survived. The switch to Falcon. That's a good point. So the thing was, you would do a CAS, And there was a state machine. Each inline cache was a state machine. And if whoever won the CAS race got the state, and then the next guy in would fail CAS, look at the state, realize it had been advanced to some other type, whatever, and would you know do his whatever backup plan is when the cache isn't the state you're looking for, which for what you're talking about would be okay. I'm going to flip you to megamorphic. And there was a state machine. These could all interleave in any order. There's only maybe two CASs because you had pieces that could span a cache line boundary, and you can only CAS add a cache line.
So you're saying it can an ICC can fall back into megamorphic state where it doesn't do the caching?
Yeah.
Okay. So in this case, all the overhead we had was basically a call to that stub instead of inlining the resolve itself.
Yeah, I don't know. Right. I don't know right. Like I said, the overhead's pretty small. It would be there is some variation of a load compare branch, and the compare and the load are one instruction on x86 generally. And the alternatives would be not the load, and the call is a call to the megamorphic, do it the hard way. So you have basically a NOP and a call to the megamorphic stub instead of just calling the megamorphic stub directly.
Well, in our case, we don't call the stub. We inline the resolve code.
Well, I'm saying if you've got a megamorphic guy, you know it's
Okay.
megamorphic. You're generating code for a megamorphic guy.
Okay, I guess all the performance improvement we got is literally because we got rid of of going to the stub and we just inlined the resolve code. So
Oh, you inline the resolve itself.
yeah, we inlined the resolve.
Yeah, you could do that. Especially if you knew it was going to be megamorphic, so you didn't inline them everywhere. Like iCaches, when I was doing it, the iCaches were not known to be megamorphic. Like they're mostly not megamorphic.
Mhm.
And you just couldn't inline the resolve lookup in every call site. You die with, there are too many of them. If you've already said it's static or megamorphic, then you've done the 95-5% split already. Now you're inlining the resolve at the 5% ratio level. That makes sense.
That's the case.
Yeah, could be. Especially if you're doing a lot of them because you're one of these.
But modest, noticeable improvement across the board. So
Interesting.
Disabling ICCs for Falcon generated code was a win.
If you looked at how Sun was doing it, it was much more expensive to deal with. They had to stop everybody and roll people forward badly to get them out of the middle of making an ICC call, and it was a lot more overhead. And so what I was wondering is if you were comparing against Sun's version, like when you flipped to Falcon, did you go back to you had to keep the GC though?
No, all
runtime.
Zing was in the same state. Like we didn't do any overhaul in the runtime.
Okay, that's what I was wondering. Which one did you grab? If you started from Sun's in and then you got rid of ICCs off Sun's, yes, I can see a benefit. You started at the Azul end of things, I guess it's Zing end of things. I claimed that the megamorphic calls were pretty cheap. The fail out to megamorphic is pretty cheap. Of course, you had an extra call, but it didn't do anything.
Yeah, I guess it's just this extra call that we got rid of when we turned it on.
Okay, interesting. I would have thought that wouldn't be huge, but I don't know. You know what? I wonder if there's another thing here with x86's branch prediction working on your megamorphic lookup. Because when there's the one I did where he jumped, the fail for the inline cache goes to the megamorphic lookup code, but all megamorphic lookup codes go to the same spot. And then since everyone's calling it from all over the place, the x86 branch predictor has no chance.
Okay, I see.
And whereas if you've inlined it, then each individual inline guy has a chance to branch predict if it's both megamorphic but has a dominant frequency. Then the dominant frequency will get branch predicted and you'll get something out of it.
Well, but we would typically handle the dominating one with the predicted types because we use this megamorphic call as a fallback from like profile guided devisualization. We would have a switch on types, and only if this failed, okay, we're going to do the dispatch.
Right.
But as I said, the difference was like not that big, so
okay.
It's not.
Yeah, I have no idea. Yeah, interesting though. It's interesting to me that you can inline for devirtualization enough to get a sharply bimodal, we know it or it's megamorphic. You give it up. That's an interesting piece. Cool. All
Yeah,
right.
I can give an example, by the way, of some of what I was talking about on the what's it called? Duck typing.
Yeah, sharing is enabled if you want to throw code up.
Sure,
I
let me
haven't
do
sorted out what I'm
this.
doing with simple and duck typing things. After methods, somewhere down the line will come single inheritance. Duck typing will wait a little bit. Or you have
Yeah,
to
let
grow
me
your
just,
font. There you go.
yeah, there. How's that?
I can read it.
All right. So quick example I just whipped up. You have some interface as basic as possible, void foo, some class, it's got void bar, and just for sake of the example, I made a derived class that adds a void foo. So you can see that D duck types to I, C obviously does not. Any questions? So here's the challenge, right? So imagine converting this into Java. You've got some compile times type C, runtime type D, however that happens, and you've got some method that takes that interface I. This one's not hard to imagine, right?
Well,
So
it's an
I'm
instance
calling
of the interface,
right. So I'm
which
passing.
by the way, I think but go ahead. I mean, you finish your example here.
Yeah, I mean that's the
That's the
the
hard one.
that's actually probably the easy one because here you could imagine.
No,
Um,
that's the hard one. As soon as I know you're an I know you've got a foo. Furthermore,
right,
the act of knowing that you're an I probably tells me where your foo is.
right, but this translate that to Java is the problem.
Right.
Okay.
Yeah, right. So there was a mindset in my head that I was just going to throw down a bogus interface. So when D is declared, I will compare it to my known interfaces and say, oh, you implement I. So I'm going to interface you as an I already.
Yep.
Now the lookup call and the is a call are both going to be, you know, cache expensive if you blow out the cache. There's a cache if you blow out the cache expensive. Not expensive in this example, but when you have hundreds of I's and C's and D's and they're all in some complicated nest, the test is expensive. Fine.
Yeah, I mean it's not a very commonly used thing, so I'm not worried about
Right.
the.
And you said not common. So I claimed that, the behavior that I'm promoting here of D implements interface I at the time that you load a class.
Now, having foreseen that, here's the next example,
Oh,
right?
I see. Yes.
So
Oh,
now I have interface a
well, you have
different logic,
generics, which were
different universe,
much more of a bitch.
right? So now you know exactly where I'm headed with this, right? So I have int foo this time, right, in my interface, and I have some. Yeah, let me make some more space here. Uh, so now I have t foo. So you want to generate this class and say that it implements I, but only for t equals int, right?
Yeah. I had that one handled, and I'm trying to remember what I did. I swear I did something stupid like there was a base G class, and then I had extensions on G classes. So I made up bogus G classes, so name mangling for victory, where when you did G of int, you got the interface
So
I on
so
that
you
named
you didn't do the
class.
duck typing, but you did work on the conditional incorporation, I think.
Yeah, those were definitely there, and
Yeah.
they did this kind of a thing. But you could
Right. So
claim interface. So when you did the G of T, um, oh, it's not G. Oh, I see. You want a G of T. Yeah. So when I make a class G, I would say there's a G of generic, there's a G of int, there's a G of however many other G's you need. And then the G of int also picks up the interface.
Yeah. So if I said do something here
Yeah.
and I pass a new G of string, as is that an I, right? Or
Well, that one
a
should
new,
give you a false. So if it's not, you get an assert. It's not right. That one fails to compile in theory.
well, the is produces, sorry, the is operator produces two values. It produces the true false for the answer to the is, but kind of like the Java instance of,
Yeah, if it
uh,
fails, what you get? You get a
you get
false
the
otherwise.
X in Java. You can say if X is instance of uh, I,
Right.
right?
You get a name. I get you get a name type. So if you fail this and you make the call to do something, what gets passed in for the do
But I
something?
believe in the Java sense, you cannot test for the generic one. So I think there was
Oh
some.
yes, yeah. Java erases everything, of course. That's a good point.
This is
Uh,
ecstasy, and right, we're doing this all
So
at compile time. We
so
have
I
to.
think abstract types mixing and the typing will create problems.
Well, I want to ask Cameron the meaning of the first call to do something. What is that meaning? Should it be a compiler error?
so this is a short circuiting operator. So no, it just doesn't. It in this case, it
Okay,
does not
it does not
call
actually
do
make the
something.
call.
Right.
I claim
But
that
why
syntax is horrific.
why do you need a runtime check? So if you instantiate here G to string, then the compiler should know that the foo is instantiated to string and it doesn't bind with the foo with int for the
Yeah,
interface
the
out.
compiler would. In this
Yeah,
case, the compiler would know. I'm trying to give you examples. If you want, I can spread it out over different modules so you can't
Hmm.
assume type information. But
right. The
again,
type
this is for
inference
conversation.
is right. I got them plenty. They've got 50,000, 100,000 lines of library code that does all of this shit all over the place. And so every one possible example, I would find one in the
Yeah,
library somewhere.
but
Uh,
but the
but
main
this one, I
idea.
claim
Oh,
the,
go ahead,
the
Cliff.
the translation to Java would be you make G with funny extra names on them as name mangled, and the one for int and one for everybody else, so you could pick up the interface. Now, if you have interfaces that are late arriving, I don't know what I would do here.
That's the challenge.
But
There's always one more
Yeah,
trip line somewhere is the challenge.
right,
So uh, uh, our plan is to actually generate a class on the fly that implements the necessary Java types corresponding to those duck typed interfaces, and it basically becomes a delegate to the original object. But yes, yeah, I saw your face, and I totally agree because now you complicate everything because you have the
right,
potential for a delegate model everywhere.
right. Like, is it worth it to have? Well, it's your decision. It's like, is it worth it to wait another decade to get the implementation running? Nah, I'm throwing
Yes,
out a giant number on
no,
purpose,
no, it's
but
it's it's a reasonable question. That's exactly how we look at it, and yeah, that's perfectly worth it. And
yeah.
you, you get the 50% performance penalty for a decade on duck
No, you
typing.
you
It's like,
get to go to markets a decade later. That's what I'm saying.
oh, I'm
I
not
mean, I
willing
mean,
to wait the extra decade. Yeah.
Yeah.
I
Well, it's
mean,
not
if
50%, it's tenfold, thousandfold. That's your interpreter solution. To
Oh
get
no,
the
no, not.
generated code version,
I'm
that's what
talking
I'm
I'm
saying.
talking the generated code version.
Yeah, the generated code version, it takes forever. Yeah, not a decade, but not short. One of the design goals I have for Simple is to actually be able to generate efficient code up front or make you do an action that you recognize is expensive, but not silently have you throw an interface in over here. Somebody accidentally matches it, didn't mean to, and now you have to like giantly either giant cost everybody or giant engineering to go work out how to not giant cost or whatever. So if you do something that will cause a difficult runtime solution or runtime issue, you have to do it. You have to say, yes, please hurt me now.
Simon, do you have a comment?
I mean, as soon as you cross module boundaries, it basically becomes a linking issue, and linking issues are usually best solved with runtime support, because there you're actually in control over when
Linking in
linking
this
happens
scenario,
and what to do on linking.
yeah,
And
linking is different here. It's like the Java linking step.
yeah,
The runtime
runtime line linking.
linking doesn't call a Linux linker. It
Yeah,
does things. So
yeah,
you get to do anything you want during link phase
exactly.
reasonably.
So in the end, you basically want to do some link time magic,
Yeah,
and
but right.
if if you can't do that, you're basically reinventing that very, very expensively by implementing it yourself at runtime. Then you have like the usual problems like it's not running at the right time, or it's running at an inconvenient time, or it's running more than once, or you need to synchronize things. But I mean, if you don't control the runtime, that's basically all you have left.
I think we'll control the runtime. We'll control the linking, but I don't even know what the magic linking thing is here. So you have some G's floating around with some generics. An interface appears that matches one of the G's generics floating around. All of the G generics to fit in the Java runtime model for an interface call have to be revisited somehow. How can you do that? What's the answer there?
I mean that's a question, right? Do you control the runtime or not? If you do like a Java runtime model, you don't have control over what you're doing when you're discovering new interfaces.
We're right. We're current theory is we're going to
And
run on the Java runtime, and so
yeah,
we're gonna
then
and we're another
I mean,
layer. So we own that layer, and then we have to talk to the runtime, the Java runtime.
yeah, I mean because like if you own the runtime, you could say, okay, I have this interface from module A, and I have this method from module B, and I have this instantiation from module C. Please compute which types that I have already instantiated fit into the function call and which don't. That's probably how I'd do it.
So the issue now is having decided that there is a collision, I need to dynamically change the existing versions of C and C, G and G interfaces or whatever, so that the next call out where a G object escapes to an interface call, it does the right call. So you have a running system, and this thread says, I make a new interface. And then somebody else says, and I make some code that takes this interface. You have some pre-existing Gs that have never seen this interface before. They get handed off from one thread to another who immediately makes this interface call. And then how did that work? So the current theory was I was making interface calls via the Java's interface call mechanism, which if everything's up front and I explain to the JVM what's going on before this happens, he does what he does, which has the inline cache baked in, and it has some, some decent interface lookup. It's a spin loop, but it's not terrible. Whatever, he
But
does his
I
thing. But
but
if
I
I
think in that case you're not getting away with both separate compilation and not having to generate something like proxy classes.
that's
Basically, the
actually
thing
a good
Cameron
point.
mentioned.
Disallow this in the case of separate modules.
I mean that's at least
Yeah,
that's my interpretation. If you say like different modules or module boundaries, my expectation is separate compilation, because if you're saying like, yeah, it's a separate module, but my compiler can look at all the modules uh, at compilation or at runtime
Well,
anyway, then
at link time
it's
you can
like,
see, yeah,
sorry?
at link time you would see the separate modules.
Yeah, exactly. It's like if you can look at it before link time, there is like you don't have module problems, but
right.
because you don't really
Yeah, and one
look,
of the challenges
because you're
with
not
duck
looking at
typing,
the hard problems.
one of the challenges with duck typing is that it is most valuable because of module boundaries. One of the benefits of duck typing is the ability to implement an interface across a module boundary without actually having access to that interface. So it's a loose coupling. It's a loose coupling mechanism,
Yeah.
and it is a hack. I just want to be clear. Duck typing is always a hack. Like there's no exception to that rule. Like Java's survived for 30 years now with no duck typing. Why is that? Because, you know, they don't like hacks, you know. So, but hacks aren't necessarily evil.
Every JavaScript programmer feels very offended by being called a hack.
Well, every JavaScript programmer should probably feel offended. That's okay. I've suffered through my share of JavaScript. I can say that I have never worked in JavaScript without experiencing hacks.
Oh, geez.
Yep.
It's
I
yeah, go ahead.
I've been just I was telling Cliff that I've spent like 1.5 days, 2 days now, deep in hell trying to implement more fully, trying to implement iterators and yielding and re-entering generators
Generators.
in the Nova JavaScript engine, which is it's a hell of a pain. Like the not only just that generators are complicated, but then there's JavaScript on top of it, where nothing ever works the way you would expect. Just today, I ran into this great thing where I had kind of led myself to believe that if you are iterating a normal JavaScript array using the normal JavaScript array iterator function, which is built into the language, uh, then you know how this thing is going to act. And I have a special case for that because this is a very common case and you want it to be fast. And sure enough, this is almost entirely true, except when you finish the iterator, turns out if somebody has actually gone and assigned a return method to the array array iterator prototype, now that function needs to be called with your array iterator, which like you've special cased it to work fast, so you don't actually create the object. But now, at the end of that iteration, suddenly you need to create that object out of thin air because, this thing existed after all. Oh, lovely.
That's because you allowed to have a function after an iterator be applied. It's just like,
Yeah.
what?
I mean, it does make sense in the case where you're using generators to do like streams and so on, where the stream needs to know when it's stopped, and maybe you need to close a socket or something. It makes sense that you have this method that gets called at the time, but also like
Somebody had
it's
a
such a
great
pain.
somebody had a great reason why Java needed finalizers as well, and those were
Yeah.
only ever a disaster. It's
I was actually reading into finalizers just yesterday. In JavaScript, they're at least relatively easy. But yeah, not looking for, maybe looking quite a bit forward to
no,
that as
no,
well.
no language should ever have finalizers as spec'd by whatever. No, none of them I can ever see that they are a non-deterministic runtime action taken at some future date, maybe never. And
Yeah.
how is that helpful?
I
Maybe you
think
will, maybe you
I
won't.
think Objective C originally could have gotten rid of it with the model they had with the everything.
But
They
then
didn't
graphic,
use pointers originally. They used handles, and so they had that giant ass handle array.
yeah,
Talking back in the 1980s, probably
yeah.
now. But
No, Java has a giant ass handle array. Every native call on the planet.
well, what I'm saying though is every object in Objective C was held in one array.
Every object? Isn't that called the heap?
Yeah,
Fine.
so they didn't have to walk the heap, for example, because they had all the objects in one giant ass array, and everything was by handle, so you always had one extra dereference. And
I see
before
what you're saying. I see what you're
and
saying. You
before
mean
Java
every
came along,
reference? Oh my God, yes.
yeah, yeah,
You slow everything down by tenfold, you don't care.
right, but everything was relocatable for free because you
Right.
were paying instead on every
For free.
access.
Yeah.
Yeah, exactly.
Yeah,
Yes,
I say
free
10x, but
input.
say 2x slowdown in exchange for everything else is free because you already paid
If it
2x.
was 1980s, then the CPU to memory cycles probably weren't that bad.
Oh, but your caches were half the size and all that kind of
Flashes?
stuff.
1980s? Come on.
Yeah,
What
so
kind?
this was definitely designed for the 68K, right?
Oh gosh,
The Motorola 68,000.
I remember that.
Yeah, it's a good chip.
I
Good,
wrote
good.
assembly for it back in the day. There you go.
That was one of the easiest assemblies to write
It was actually. It was pretty decent.
because they actually designed it, unlike Intel.
Intel walked backwards into theirs. Yes, it's true. Fine.
Hmm.
No, what I was thinking, somebody was doing ref counts with finalizers, Python. And I thought Objective-C too. And when the ref count went to 0, you ran the finalizer, which was way more deterministic than Java's GC-based finalizers. But then you had to do ref counting. And then everyone who optimized the ref counts, and there were plenty of folks who wanted to speed up Python, and they would start with optimizing ref counts, changed where the finalizer ran. It still was much more eager than Java finalizers, but I remember hearing screaming and yelling when, look at this cool ref count optimization we do. And then cut the cost way down and we still catch everybody and da 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 da, but you changed where the close happened on the function call. Wow. I still think no finalizers. C++
There's always,
destructors,
I was going to
scope-based.
say RAII and C++. Yeah.
No. So the scope-based destructors make sense. I use them a lot. I love them.
Hmm.
I started it here, and then on every exit path, the thing happened. It was a scope-based. I locked it, and the unlock happened on exit. Fine. I opened it, it closed on exit. Fine. Not a little bit later, which would be okay if it was always the same, but then you couldn't optimize. What was it, Hiram's law? You exposed the exact ref counting technology. And then, of course, Java Finalizers was like, yeah, maybe. And oh, your heap got bigger, so even more later. Oh, you ran out of OS file handlers because your heap was so big that we didn't bother to run finalizers. So your Tomcat Apache server crashed and burned for out of file handles. Run with a smaller heap. No, stop.
Yeah, the file handles thing is still a problem today, believe it or not. And I think Kubernetes has run into some issues with that.
Really? I thought that
Yeah.
would be beaten down fine, but maybe not. There was definitely an era where people put in system.gc to try to get their file handles back. And there was an era when the GC guys all had hacks that said, we'll count the number of finalizer objects out there. And even though there's no other reason for it other than, we have a bunch of them, we'll go ahead and run the cycle to see if we can clean the finalizers out. But that caused a lot of bogus cycles, GC cycles to run. There's a third or fourth stage of file handle shenanigans. I think
Yeah, I remember.
heap ByteBuffers and direct ByteBuffers. I've run out of direct ByteBuffers before.
Yep.
And a fairly recent one. That was H2O, wasn't that long ago.
Yep.
And
Same.
he had a combination of OS finalizers and you could explicitly free them. And there was a third release option available. Oh, try with finalizer, whatever. Try with finally. There are 3 ways you could get rid of them, and then you still could run out if you didn't do whatever things because you were waiting for the OS to run heap finalizers. And we were doing.
Yeah, it required like 2 iterations of the full GC before they'd come back or something. It was awful.
Oh yes, the return wasn't great either. So we were like running giant big data. So one of the things you do is say have a giant heap. So the heap
Yep.
never ran. I mean, the full GC cycles were rare, so you couldn't get them back that way. But we solved ours by explicitly deleting them and had to track. I think we ended up with a pool that we managed ourselves for the direct byte buffers. I remember
Yep.
screwing around with that forever. Oh, here's my face
Yeah,
turn
you
red. Somebody was talking about that. The lighting changes.
you have to you have to pull them if you're using more than a few of them. And we were doing 40 gigabit InfiniBand at the time. So and with round trips, you couldn't throw away the buffer until it got act until you got your act
Yeah.
from the other end. So
Right.
you could be, if the other side was GCing for a couple seconds, you could have 128 gigabit of buffer just for that one connection, right? Because you're throwing it
Yeah.
across the wire at wire speed. And anyway,
Yeah. H2O knew how to regenerate the contents that it sent. So I didn't have to hold it in a direct byte buffer. But we still had the problem that you needed a lot of them and the flow rate was extremely high and they would stack up. And yes, you had to hand manage them. Yep. All right. No finalizers and simple.
The problem with GDC actually reminds me, I think this might have been discussed at some point, but there's a fairly interesting paper, I think, year and a half ago, on basically solving GC timing by just analytically analyzing, or no, algebraically analyzing the rate of GC versus heap size versus like live items,
Yeah.
live memory versus dead memory. And they came up like it was a fairly simple mathematical formula that they used to analyze this and came up with, okay, like the thing that you should do is take the square root of the released memory or something like this. And then, they got out this lovely, like no longer a heuristic, but just an algebraic result. This is when you should GC based on your, like you do
Yep.
a clock every 1 second, you check how much memory has been allocated.
Right.
You compare that with your live memory. And as the time goes on, eventually you will always GC because you like, even if you do really low allocations, it will always eventually find that,
Yeah.
the difference is small enough or something like that.
It-
That was really interesting.
Azul runs I don't do now, when I was there, running a heuristic that was very analytical in nature, that was measuring the flow rate of allocations and the flow rate of what you're getting back from the incremental GC things that are going on. And do we need to bump up the rate of incremental collection to stay ahead of, to stay ahead of the mutator consuming? And then the mutators would have spiky starts where they would say, geez, I'm about to do a big job, so let me go allocate, a couple hundred gigabytes. And then the allocator would panic and try to start freeing up space ahead of a higher rate of allocation, and the spike would die off and whatever. Yeah, there was a lot of analytics there. That was a pipeline flow rate problem, kind of. Network flow rate. All right. Well, I'm kind of amazed that no one jumped up and down and complained at my simple code. It's too easy, too hard, too this, too that. No complaints. Fine.
The main thing would
Not
be
today.
to run once it runs. So
Run. Yes. Well, like I said, it's getting very close. I'm now hitting the bugs that you hit when you try to, use it in anger, whatever. Much larger test cases. It needs some beaten on to get it to be a little more stable. On the other hand, now's the time to say the language sucks for makes these changes. I don't know if I mentioned Cameron. Yeah, man, you were on when I did it. So I think the no, locals should not be final by default. That was getting too aggressive. Matt was complaining about it, but no need for it. But Matt's also doing parallel things with multiple cores in the same code, and he's trying to express some level of parallelism, which I'm not there yet. There's
Well,
a
there are
thing
people
going
who
on.
build languages and people who use languages, and they
There you
don't
go.
always have the same opinions on these topics. So I notice a lot of Matt's opinions. No offense, Matt, you're brilliant, but a lot of your opinions are only useful for language builders and completely horrible for language users. So
If fair, the parallelism thing comes from the usage experience. So I've done parallel number crunching for more than a decade before I became interested in programming languages, and I really hated that I had to manually put const because the compiler couldn't infer it. And that was the easier way to go. So some of this is just experience.
so now that you're working on the compilers, you're going to fix that, right?
I learned there's this thing called standards committee, and it doesn't seem to move immediately fast.
Yes. You see, you change languages. Compile in on simple.
Or do what GCC does. Just add random extensions to the language and pretend it's real.
Well, it is. GCC adds it.
So being that the simple is expanding for was the module story, would you allow to import
Oh, yeah,
different
modules. Yeah,
files?
I had a brain fart over this week. I thought I would do is put the module interface, enough technology for the module interfaces in the .o files. And when you compile a simple function, um, if you want to use an import from another language at the compile time, you need to mention, it's like mentioning the classes on the class path for Java C. You have to mention the .o files on the compile line for the simple, and he'll open the .o files, extract out of the ELF file the module headers that you're talking about, and then let you cross compile that way, or pick up the signatures that way.
Meaning
That was
importing .o files like libraries, like already compiled thing to import this functionality, or
we have a .o path, like a class
Mhm,
path on the compile
mhm,
line.
mm.
This is not what the language syntax looks like. This is, I just said, simple compiler, I'm compiling this simple file, dash class path, O path, whatever,
Oh,
and then here is,
supply the
yeah.
okay.
And then you go read those and say, okay, this is, you're extending your namespace by having these other things.
Okay.
Then, when is something going to be in a extended exposed? I'll probably say there's some way that you define how you write something will be exported or not.
Mm.
Um, I've had a theory for a while that if you use either an underscore to say local or capital to say exported or anything like that. So there's a module boundary based on the name,
Mm.
as opposed to a keyword that says export this. So in C, you'd say export this. And in Java, it's public, private, whatever, but always the main class, and there is a main class that is exported. Simple is a class-based file tied to a class-based. So if you have a bunch of things in a file, what of them get exported and what don't? And some way to define it.
That would be a consequences also from how aggressively to optimize that. If it's being exported, that means it has to be visible. You
Yeah,
cannot just get rid of it. So
right. Yeah, absolutely. That's part of it. You can't inline it to death, but if you don't export it, you can. No, fine.
Mm.
Also, throw things in the .o file means at a future date I could get to whole program compilation done by pulling up a simple compiler with all the .os and just have it cross-compile, cross-link across all the .o files.
Mhm.
So .o will have signatures, maybe, but at some point it might have IR directly. And then not only will I get your .os, but I might decide that some of those .os that you're calling, I'm just going to inline, and I can inline them right now. So that's a theory. I haven't decided in practice it works or doesn't. Leads to the same management issues you get with anybody's collections of .os. If you change some of the .os and not others, and you didn't rebuild, then the calls don't make sense or whatever. The linker gets confused. So there's probably something needs to happen in the .os to have a version number, signature, SHA, hash, whatever, so you can't accidentally mix and match. guess mixing and matching is good if everyone agrees on the same things, but I guess it's bad if I modify something and then you're got the wrong guy. The next guy down the line gets the wrong guy, something like that.
Okay, cool.
Yeah, I mean, it's a half-assed theory. Sounds kind of interesting.
Yeah. So certainly you will include all the dot outs into the same namespace. So because you have to
Yep.
wait for all the symbols to be found.
If you have a cross module, I've only half heard your question.
Yeah.
There is an issue where module A refers to something in B and B refers to something in A, and I don't have either one.
And you have to wait. Yeah, that's my question.
Oh, no, I have to have them. I have to have both sources to compile at once.
Mhm.
If I have an A and he calls a B, and I have a B source and he calls an A, then the first compile requires both A and B.
Mm, mm. Okay.
Now I
So
have A and B in the .o. If I modify A and I don't modify B, presumably I can keep the same B's from my .o file.
mm,
And when I make the A's .o file, he changes, but he still makes references to a B.o file.
would that be valid? So
Yeah,
mm,
I think it can be made valid. It's like same with Java C. If you have classes and A makes a reference to B, if you call Java C, he picks up the source code for B. At the time you're compiling A, he demands have access to source code for B. So you can import the B definition in A, and he compiles them both at once. Then he throws out class files for A and B.
mm, mm, mm,
And now you don't need both of them simultaneously to start with.
mm, mm.
But
Okay.
when you say compile Java C of A.java, and he makes a reference to B and there's no B class file, he pulls up B.java, parses it. So I'm saying the command line launch for A.java pulls up B.java and silently behind your back has to be
Yeah,
found on the class path or he'll fail.
that's a cycling dependency. So
Yeah.
yeah.
So now is that experience? So I'm proposing a slightly different experience. When I pull up A.java and there is no B.o file lying around, or A.simple, there's no B.o file lying around, I'll complain at you and say, I don't know what the reference to B is. So
And
you better
also
compile A.simple and B.simple at the same time.
precedence. So you have a dot Java, you have a B.o, you have a so you
Yes,
yeah.
yes. I think I can do that one by saying if you add a B.java to the command line, I'm compiling that B.java.
Mm.
If that B.java is dated properly with the B.o, maybe there's a shortcut. I say it's dated properly and there's a SHA that worked.
Mhm.
I'll claim I can not rebuild the B.o.
Mm. Yeah. Okay. So are we assuming that will be some kind of delay in compilation because in the source in the dot simple source you declare something that you don't have. You have to parse all the .o files and you have to wait there or you declare a forward reference or something. So I assume
Within a
that.
single simple file, you can have a forward reference,
Mhm.
but it wants to be resolved before the end of the compilation.
Mm.
So if
So
I'm doing cross modules the same way, I'm going to demand while compiling A, I find a reference to B, make it a forward reference and carry on. When I get to the bottom, okay, I got some B's here. What do I do with them? Well, I better find a B.java or B.simple on the command line, go compile it.
by the end you have to have it resolved. Yes, cool.
Yeah, you have to have it resolved. So in C, you get this, I have a header that I hand wrote separate from the body, and the header tells somebody else what it looks like, and then you link. But when you compile A.C, you just need the header for B.H. You don't need,
Because there's just the descriptions in order to find the symbols it needs, and that would come later. So
right. And I'm saying I'm not going to have a split file, a .h and a .c. You
mhm.
get the one simple file, but if you want to make reference to somebody else, I'm going to have to find it somewhere, have to hand it to me. And why not use a .o format to hand it to me? as well, because the Dado format also has other stuff you need to run. It has your generated machine code and whatever else. So might as well use the Dado format to hand it to me.
Okay.
I'm hoping Matt will jump up and down and tell me why I'm being stupid and why. This doesn't work, right? I'm hoping it works. Okay.
It actually does seem reasonable, but what else? What is the alternative?
Do it as a split file, which is what C does. You get a .h and a .c, or Java where you have the source path is put on the command line, and you have to have the source available. So I'm in the, instead of having a class file format, I'm going to have a .o format. Does it matter? I don't think it does.
If you can pick it from the .o, why not?
Right, right. There's some extension place in the L file I can just jam when I want.
The
Okay.
difference would be you cannot make optimizations on a .o file, but you can still make optimizations if it was a source.
No, I can make optimizations come out of the .o. I was just talking about a second ago.
Oh,
So you put the headers in there or the signatures you need to link against,
okay.
but you can also just put the IR in there.
That's different. And
It blows
yes,
up the .o file, but whatever.
Hmm.
Depends on
If you-
how big you want to get.
Yeah,
How compressed is the IR? Is it actually small enough? Maybe you don't care if your .os are big.
But why,
It's small.
if we are embedding the whole graph, why do we want a .o file?
Because
So-
everyone on the planet has technology and understands the .o, and this is essentially the meaning from a usability building the final executable standpoint. It matches what the .o means.
Hmm.
So just leverage everyone's existing .o technology.
Yeah, it's a good plan. So
You want to reuse the build systems, basically.
Yeah.
Right.
Yeah. Reuse the build system. Yeah.
I mean, to an extent, that also is what is done in LTO. When you use, say, Clang with LTO, it's just going to embed LLVM IR in the object file. So you do have fat objects, essentially.
Right. But then if somebody's got a C cache or whatever it is, parallel cache building technology for this thing, it all just works. Should be the same.
Once you do have IR, of course, you could do more, because you could do things like checking the safety, link time safety checking, or link time type safety checking. Even if you have interoperability with another programming language, as long as that programming language still compiles to this IR. There is some work done on that, both in a Camel and Rust interoperating with C. If Rust calls C, how do you know that function is safe? Well, we can actually analyze the IR.
Oh, I see. Well, if you're going to give me the IR, then I don't need the exe. I'm just going to run the IR straight in. And you're as safe as my compiler. Never mind what your compiler would have done. I mean, all of these things have the whole who do you trust at the bottom of the stack.
We should have had better linking technology by now. I mean, there's so many things we could do at link time that we don't.
Where's Yasser? Yes. Well, I mean, that is one of the things that Java kind of did, and did it well, was the link time is while you're running, and I will link as you load it. And then now that it's linked, whatever that means, those bytecodes get inlined across all compilation units, and everyone does optimizations there. And
If only we had a portable IR that you can run once, run everywhere. I think WebAssembly might just do it.
Exactly. When I started the whole AA simple line of thinking, there's a goal to say I'm trying to make another VM out there that's not tied to Java bytecodes, doesn't make the mistakes that JVM made. JVM has a huge amount of benefits to it, but he makes mistakes that you can't do other things that you would love to have. And is there a way to go? What do you want to do? How do you head to that path? Since it's, basically it's me and a handful of volunteers to sort of creep it along here. Takes a while to get there, but trying to make something that eventually might be suitable as a runtime for all kinds of things.
It's a good goal.
It's a good goal. Fine, keeps me busy.
Keeps you out of trouble.
Keeps me out of trouble. Or into trouble, depending on which way. I'm too much here and not enough there. I have to go do other things for a while too. But yeah, actually, it did warm up here. So, all right. Anything else? Gonna call it in a minute here. All right. Let's say it's a good deal and till we meet again. All right,
Cool, cool.
folks. Bye-bye.
Bye.